Hello everybody, and today we're going to be doing the most awesome math question you've ever seen. Here it is. A farmer wished to create a rectangular enclosure, ABCD, of area 525 meters squared, as shown below. As you can see, there's a square with its sides ABCD, X being this side and this side, Y being this side and this side. The fencing used for side AB costs $11 per meter, only for this side. The fencing for the other three sides costs $3 per meter for this side, and this side. The farmer creates an enclosure so that the cost is a minimum. Find the minimum cost. So to start this question off, it requires a little bit of basic calculation using the area knowledge that we have. So area is X times Y, the area of this rectangle. And we know that the area is 525 meters squared. So 525 equals X times Y. Rearranging this formula gives you Y is equal to 525 over X. Next, you use this information and input it into the cost formula, which is in essence the thing that needs to be minimized. So we know the cost formula goes something like this. $11 for one side AB, which is represented by X, so therefore 11X, plus $3 per this side, and this side, per 2Y and 1x. So it gives you the cost function of 11x plus 3 times 2y plus x. Inputting y equals 525 over x removes the y variable. So the cost function now looks like c equals 11x plus 3 times 1050 over x plus x. You expand the 3 out, you get the following. Then you combine like terms and remove the x from the denominator and you get your final cost function, 14x plus 3,150 times x to the power of -1. Moving forward, you need to find the derivative of this. This is as simple as solving for the derivative of each individual entity. So 14x being 14, and 3,150x to the -1 being -3,150x to the -2. Now you have the derivative of the cost function. And we know that in order to minimize that, you must set it to 0. Setting the cost function equal to 0 and solving for x will give you side length x that is needed to minimize the cost. So set it equal to 0. You move the 3,150x to the -2 over to this side. You multiply out the x squares on either side. And then you divide 3,150 by 14 to get 225 equals x squared. The square root of that is 15. 15 meters is the length of the x side to minimize the cost. The final question is asking you though to find the minimum cost, which simply requires you to input this derived x value into this equation here that is only in terms of cost and x, which gives you the final step. Minimum cost equals, as we can see here, 14x plus 3,150x to the -1. Inputting the fact that x equals 15 in for x here and x here gives you a final minimum cost of $420. Enjoy your 7.